Welcome to the 5.3b lesson. Make sure you have a calculator, a pencil, and your Unit 5 note packet open to the 5.3b note sheet. What you see in front of you is example 1. Pause the video and write that down next to the 1 in the first chunk. Equations that have two operations in them require 2 steps to solve them. You practiced this yesterday. How is today different than 5.3a? The rational numbers that we're going to have in our equations are going to be in fraction form, decimal form, integer form. We're bringing it all together. You can see that in this equation, we have 2 operations, multiplication and subtraction. In other words, to get that variable by itself, we're going to need to undo 2 operations. Now, the tricky part comes in being, well, what do we undo first? The subtraction or the multiplication? I want to remind you of something. Back at the beginning of the year and in previous years, we worked on applying order of operations to simplify expressions. Look at the left part of this equation. 75 hundredths times p minus 7, that's an expression. And before, when we would apply order of operations, we would know what p is. And our job was to find what the expression equals. So we would use order of operations appropriately. Well, now we know what the expression equals, and this time we're missing part of the expression. So we need to undo the order of operations. Whenever we're solving equations, we're always applying inverse operations or inverse concepts. And in this case, the inverse concept is we are undoing the order of operations. So we're going to look to start with addition or subtraction. In this equation, what do we have? Subtraction. So that's what we would undo first. Then we would look for multiplication or division. In this equation, what do we have? Multiplication. So that will be what we undo last. Now, yesterday we learned about, well, this is the math behind it, but it's a lot more fun to go to a party. So when we're solving 2-step equations, let's pretend we're at a party. Go ahead and draw the line down in your notes. Now, at a party, you are the variable. If you think about it, your eyes go right to the variable when you see these problems. And when people come to your party, their eyes go right to you, or they look to find you. You're the host. Now, at a party, you invite 2 types of friends. Those that you're the closest with, hence why they are the closest to you, right? That number's the closest to the variable. So it's your BFFs. And your acquaintances, people that you enjoy being around, but they're not necessarily your BFFs. Now, dad, uncle, grandpa walks down and says, it is getting late. We need to send some friends home. Who are you going to send home first? Your BFFs or your acquaintances? Your acquaintances. So let's start with the minus 7. What's going to get them out the door? If we add 7 to both sides. So now, once we do that, our acquaintances are gone and we're just left with our BFFs. So we're hanging out, we're having a good time, but then mom, aunt, grandma walks down, whomever's with you and says, it's getting late, it's time to send our BFFs home. Well, what will get our BFFs through the door? This is multiplication, so we need to use the inverse. To get our BFFs out the door, we need to divide. We're going to divide both sides by 75 hundredths. Remember, our goal is to find the value of p. So we want to get the 75 hundredths out of there. Our BFFs have to go home. On your calculator, type in 18 divided by 75 hundredths. What do you get? 24. P is equal to 24. And you know what? We solved that equation applying all the math the right way, but doing it in a party fashion. Let's look at example 2. If you didn't finish filling out example 1, maybe you need to rewind a part of the video and get those steps down in your notes. Here's example 2. Write it down in your notes. We have 5/10 times y plus 3 equals 65 hundredths. I'm going to challenge you to pause the video and try this one on your own. Come back and check your answer with mine. When I solve for y, I get the value to be -4 7/10. If you didn't get that, pause the video again and go back and look and see how your work differs from mine. Any questions, go ahead and jot it down in the left-hand column of your notes. Example 3, write this one down. -10 5/10 minus x equals 15 8/10. Let's have a party. Go ahead and draw your line down. Remember, it's like the door. There you are. And believe it or not, you do have some BFFs at this party. Since you have a -x, remember there's that invisible 1 in front of a variable. So this is really a -1x. So you do have a BFF. Let's start then with our acquaintances. Let's get the -10 5/10 out of there by adding 10 5/10 to both sides. When we add or subtract decimals, we line up our decimal points. So we are left with, this is now out of there, we're left with -1x, which we can just write as -x equals 15 8/10 plus 10 5/10. Use your calculator if you would like to. That's going to give us, let's see, 26 3/10. Am I done? No, there's still a BFF at the party, right? -1 times the x. So we need to make sure that we divide to get that multiplication and that -1 out of there. Divide by -1, divide by -1. This is going to leave me with now +1x, which I can just write as x, equals, and on the right side, that's going to give me -26 3/10. Double check, plug -26 3/10 in for x in the original equation. Use order of operations to simplify the expression, and it should give you 15 8/10. Here's example 4. Write it down, and then I'm going to challenge you to solve for x on your own first. Come back and check your answer with mine. Pause the video. When I solve for x here, I get the value to be 85 7/500. Something to point out was we had this part of the expression right here, -x divided by 2 5/10. We have a big group of besties going on. And we got this group of besties out of there, but then we still had a best friend that was connected with us that we needed to say goodbye to. The party was ending, and that was the -1 best buddy. So at the very end, to get rid of the negative in front of the x, we had to divide by -1, divide by -1. If your answer didn't agree with mine, pause the video and see where our work differs. Any questions with this on the left-hand side in your notes, go ahead and jot your question down and be sure to ask when we come back together. Moving on to the second chunk, now we're going to be working with fractions. Here's example 5. Pause the video and write it down in your notes. All right, let's bring that equal sign on down, or there's the door at our party. Here we are, we're connected with our BFF. Let's get our acquaintances out of there first. So that would be the -7. What will get the -7 out of there? If I add 7 to both sides. So let's add 7 to both sides. That leaves me with 0 there. And I have 4/5 n equals 9 plus 7 is 16. All right, it's time to say goodbye to my BFFs. The party is ending, so we need to get the 4/5 times out of there. What will undo the multiplication? Division. But we know that when we're dividing and fractions are involved, we end up multiplying by the reciprocal. So instead, let's multiply by the reciprocal right away. What's the reciprocal of 4/5? 5/4. So we're going to multiply both sides by 5/4. This gives me 1n, which I can just write as n. Oh, there are no surprise BFFs left, right? There's no negative in front of it. Woohoo! Okay, on the right side, we have, whenever we're working with fractions, anything we need to, make it improper, and then we simplify before we multiply since this is a multiplication with fractions, and I just see one spot where I can simplify. 16 and 4 share a common factor. 16 divided by 4 is 4, and 4 divided by 4 is 1. So I'm left with just my numerator. 4 times 5 is 20. Miss Kluber, why'd you say just the numerator? Because the denominator is all ones, right? So n is equal to 20. And I would check. I would take 20 and plug it in for n, apply order of operations, and make sure I get 9. Let's look at example 6. All right, it's another challenge opportunity. Pause the video, write down example 6, you solve for x, come back and check your answer with mine. When I solve for x on this problem, I get it to be negative 33/4. I'm going to leave it improper since it's not a real-world problem. If you didn't get that value for x, pause the video and examine the work in front of you. See how your work differs. If you have a question, write it in on the left-hand side in your notes. Let's try this one together. Here's example 7. Go ahead and write it down. 9/10 x minus 3/5 equals negative 7/5. Bring that line down, reminding us to maintain equality, or it's the door to the party when we have to say goodbye to people. Here we are at the party next to our BFFs, the 9/10s here, so we need to say goodbye to our acquaintances, the minus 3/5. But we'll get that out of there if I add 3/5. I like to, when I'm adding and subtracting fractions, multiplying and dividing, I guess, I like to see them next to each other. So I'm going to switch that over here. I'm adding 3/5. This is going to give me 0. I'm left with 9/10 x equals negative 7/5 plus 3/5. How many fifths do I have? Focus on the numerators, right? Negative 7 plus 3. Then negative team 1, by how much did they win? 4. So negative 4/5. Now, we need to say goodbye to our BFFs. What will get the 9/10 and the multiplication out of there? If we were to divide both sides by 9/10, which we could, but we know that when we divide with fractions, we end up multiplying by the reciprocal. So let's do that right away. On the left side here, that's going to leave me with 1x, which I can just write as x, just me left at the party. Now I'm multiplying fractions on the right, so simplify before you multiply. I see one area where I could simplify. 5 is a common factor. Now I do have a negative here, so negative 4 times 2, that's going to give me negative 8. And in the denominator, I have 1 times 9. So negative 8/9 is the value for x. I'm going to take that, negative 8/9, I'm going to plug it in for x, multiply 9/10 by it, then subtract 3/5, and I should get negative 7/5. Check that. Anything that I said or wrote in front of you that you're not sure you have a question about, go ahead and put that on the left-hand side. Pause the video and write yourself a little note to ask when we come back together. All right, last example on the front side. Pause the video, write it down, and I'm going to challenge you to solve this one on your own. Then check your answer with mine. Pause the video. When I solve for x on this, I get it to equal negative 6. Go ahead and look at my work. If there's anything that doesn't match yours, take note of it. Change it in your notes. If there's something that you're not understanding, a number, where it came from, why I did something the way I did it, according to what you see in front of you, make a little note on the left-hand side of your notes. We have 2 more examples to do together. Flip to the back of your notes when you're ready. Example 9 and 10 are 2 real-world problems. So how do we solve real-life problems using two-step equation? We are going to write an equation for the situation and then solve. A quarter of the students in Mrs. Kluver's class and 7 students from Mrs. Johnson's class are in quarantine. If there are 15 students in quarantine, how many students are in Mrs. Kluver's class? What are we trying to figure out in this problem? How many students are in Mrs. Kluver's class? So blank students are in Mrs. K's class. So we know the variable above is going to represent students in Mrs. Kluver's class. So let's let K represent that. Let's go ahead and let's read line by line, look for important operation, words and phrases, and important numbers. A quarter of the students from Mrs. Kluver's class. A quarter of the students from Mrs. Kluver's class. Hey, that's what I squiggly lined down here. That represents a number and we don't know what that number is. We're going to let K represent that. When we're taking a number of another number, of means what? Multiply. So that's our multiplication word there. So let's pick it up right here again. And 7 students from Mrs. Johnson's class are in quarantine. We also need to know how many students in Miss Johnson's class are quarantined, right? Because it gives us the total then. So 7 students from Mrs. Johnson's. If there are 15 students in quarantine, hey, that represents the total there, right? How many students are in Mrs. Kluver's class? Well, let's go ahead and let's translate this and write it down. 1/4 of Mrs. K's students, and, oh, you know what? This and right here, now that I'm reading it, it means plus, right? And 7 students from Mrs. Johnson's class are in quarantine, and we know that there are a total of 15 students in quarantine. How many students are in Mrs. Kluver's class? Here's our 2-step equation. We're ready to solve. So let's bring down our equal sign. There we are at the party next to our BFFs. We got to send the acquaintances home. So we're going to minus 7. We're left with 1/4 K equals 8. Now it's time to send our BFFs home. We're going to multiply by the reciprocal instead of dividing because that's what we would end up doing anyway. So we're going to multiply by 4/1, 4/1. And this gives us 1K, which we can just write as K. I'm going to have to go over here. Equals, if I look right here, it's just going to end up being 8 times 4, which is 32. So 32 students are in Mrs. Kluver's class. Final example for today. I am going to challenge you to try this one on your own. Come back and check your work with mine. When I solved for how many miles she traveled to the airport, I got my answer to be 38. Go ahead and look at the different markings that I made in the story problem. Again, I'm using the marking the text strategy to help me do this. Then go ahead and examine how I solved the 2-step equation. So pause the video and compare my work to yours.